In the previous section, we introduced the concepts of star and snowflake schemas and very briefly looked at some high-level examples of each. Now let's dig into both and take a detailed look with plenty of examples of how we design our data warehousing dimensional tables. Let's set the stage for our examples and discussion by reviewing a couple of foundational concepts. Remember that when we refer to a dimension, we're using the data warehousing terminology and then also the implementation mechanism for this conceptual idea of providing context for our measurements, which we'll refer to as facts. A dimension is not the same as a dimension table, even though sometimes we use those terms interchangeably, but especially for this discussion, you'll see how the two are definitely different concepts. When we refer to a table, we specifically mean a relational database being used for our data warehouse. And again, in a relational database, as we saw in a previous video, each row of data requires some sort of a primary key that's unique to uniquely identify the data that's in that row. And then in data warehousing, our best practice, our basic guideline is to use surrogate keys rather than natural keys for the primary keys. So let's look at two representative dimensions, faculty and students. And let's first focus on faculty. So here we have a faculty dimension table, and notice that the name of the table has a DIM suffix. Now, you're not required to do this, but it is a good practice to go ahead and do this for your dimension table. So if you're looking at a long list of tables or a very complex diagram, your dimension tables kind of jump out at you. So within the faculty dimension table, you see a number of different database columns, and again, think of them as fields: faculty ID, last name, first name, the year someone joined the faculty, and what his or her rank is. In the case of the faculty dimension table, faculty ID came from the source system where this data was actually created in the first place, and faculty ID is the natural key of that particular table. However, remember, our guideline is we're supposed to be using surrogate keys rather than natural keys for our data warehouse's primary keys. So what that means is we'll have an additional column we actually add as we define the schema for these tables, and say faculty key is going to be a surrogate key and it will be the primary key for the faculty dimension table. So faculty ID is a natural key, we're just not using it. So let's go over to students for a moment. Here, following that same guideline, we have student ID, which is the natural key for the data coming in from the source systems. However, we're using student key as both, well, it is the primary key and it's being used, it's created as a surrogate key. It's generated within the data warehousing environment itself. So make sure you have a good handle on our earlier discussion about primary and foreign keys, and then also natural and surrogate keys. So, with regards to the dimension tables, we'll set those up for our key data warehousing subject areas, and specifically those subject areas that are providing context to are the measurements that we're producing from our data warehouse. Within a dimension table, the basic guideline is to include as much meaningful information about that particular dimension. So whether it's faculty, students, a campus building, an academic department, a college, whatever that dimension happens to be, include as much meaningful information as you can, because basically that becomes, those tables become one-stop shopping for each of your respective dimensional subjects by having a bunch of information pooled together. Now, let's take a look at the difference between a hierarchical versus think of it as a flat dimension, because this is where our star and snowflake schema discussion becomes very important. So let's put faculty and students side by side. Now notice that faculty members are part of a department. Each department belongs to a specific college. So that's kind of a hierarchical set of dimension tables, or just dimensions, whereas students don't belong to any sort of a hierarchy. So that's an example of a flat dimension, and that becomes very important as we build out our star or snowflake schemas. So let's look at a star schema version, and let's actually flip the order, the sort of top to bottom order of college, department, and faculty, because this way it will more naturally represent the way we'll set up the data inside the dimension table itself. So college is still the top of the hierarchy, department is the middle level, and faculty the the bottom level, and you see the internal arrows are pointing that way. However, look over at the faculty dimension table where we've pulled together the fields from faculty, from department, and college all together. Now notice within that single faculty dimension table, we have 3 different ID fields: faculty ID, department ID, and college ID. Each of those are the natural keys of the respective levels of that hierarchy, and essentially each of those is its own separate dimension. Whereas faculty key, though, is the single column, the single field that's being used as a primary key. And again, as indicated by the word key, it's a surrogate key that's generated within the data warehouse. So that table had 3 natural keys, but the actual official formal primary key is the surrogate key of faculty key. Now let's take a look at a Snowflake schema version of that same actual data. So notice we have a faculty dimension that's linked to the lowest level of that particular hierarchy, and it only has information in there for now about the faculty. It doesn't have information about departments or colleges. Likewise, we have the department dimension table, which has information about the academic departments, and then the college dimension table, which has information about the various colleges: engineering, business, liberal arts, etc. Each of these tables has its own primary key, which is a surrogate key: faculty key for the faculty dimension, department key for the department dimension, college key for the college dimension. So compare that to the star schema version with all of this data in a single table and only faculty key as the unique identifier. So right now you can see a structural difference between a star schema and a Snowflake schema, not only with regards to the numbers of tables, but how the unique identification works. Typically what we'll do if we're modeling a star schema or a Snowflake schema, but basically a relational database, instead of circling fields, what we'll do is put a left paren PK for primary key followed by a right parenthesis after faculty key, department key, and college key in this case. So whichever column or columns are being used to represent the primary key, this is kind of the semi-official way of designating that. Now, let's shift our discussion over to foreign keys, and remember that a foreign key is some other table's primary key, and we use it to officially designate some sort of a logical relationship between values and rows in one table versus another. Notice, let's go back to that same hierarchy. You notice in addition to the data about faculty in the faculty dimension table and department in the department dimension table, we've added a foreign key. So for any given row in the faculty dimension table, we will also have the department key. So remember our discussion about primary and foreign keys. We're using surrogate keys here. So what this means is for any given faculty member, on his or her row, one of the last things will be the department key, which indicates the department that that particular faculty member belongs to. And likewise, for every department, after all the information about the department itself, you'll have a linkage, a foreign key relationship to the college. Now, let's look at the college dimension, which is the highest level of that hierarchy. We don't have a foreign key up there, and you might be wondering why that's the case, and that's because there is no higher level. College is the highest level of this hierarchy. The reason we have the foreign keys in a Snowflake schema is to basically make a linkage to a higher level along a particular hierarchy. If we're already at the highest level, we just don't have a foreign key. So that's you see a difference structurally between the dimension tables at different levels of the hierarchy. So let's talk a little bit about the rules. So basically, you're going to have one table in a Snowflake schema for every level of a hierarchy. Every non-terminal dimension, so a terminal dimension would be those at the highest level, a non-terminal dimension would be every other dimension table. Every non-terminal dimension has a primary key, which is a surrogate key. So in this case, it's faculty key in the faculty dimension table and department key in the department dimension table. Then it also has the next highest level's primary key, which again is a surrogate key, as a foreign key. So department key is the next highest level above faculty, so it's a foreign key in the faculty dimension table. And likewise, college key, which comes from the next highest level, is a foreign key in the department dimension table. Then we have terminal dimensions. So these are the highest level along any given hierarchy. So it also has a primary key, which is a surrogate key, so college key in this case. But there is no hierarchy-based foreign key that you could put there because there's no higher level to point to. So let's look at a graphical picture of a snowflake, but let's introduce a little bit of a complication, specifically in the form of branching. So you have some sort of a fact table which has a time dimension to it. So you see day as the lowest level of that time dimension. We see days are within months, but notice we have a split there. Months can follow kind of a calendar or a fiscal calendar or an academic calendar. So months can be part of a fiscal quarter or they could be part of a fiscal year. Months can also be part of a semester or they could be part of an academic year. So we have a split there. Now, the way we represent that within our data is we'll have our day dimension over on the right-hand side. So notice day key is the primary key. It has a foreign key of the next highest level, which is month key. For the month dimension table, it has its primary key of the month key. But notice it has foreign keys relating to each of the branches. So semester key is the foreign key relating to the semester that particular month belongs to, but it's also pointing to a specific fiscal quarter as indicated by the fiscal quarter key. So we use a combination of more than one surrogate keys as foreign keys when you have branching involved.